Okay, so this question says that we are given some numbers and it is guaranteed the numbers are from 1 to k. And all we have to tell is the minimum subsequence size that cannot be formed using this array. So from this array, if we have to get a subsequence of size 1, can we form every subsequence having 1 to 4 of size 1 from this array? Yes, can we form every subsequence having numbers 1 to k of size 1 from this array? Answer to that is yes. Okay. Can we form every subsequence of size 2? If I give you, let's say if I give you the value k is equal to 5 or k is equal to 2 initially, what are the subsequences of size 2 possible? There you can repeat the number also. What are the subsequences of size 2 possible? If k is 2, let's say I don't give you any array and I ask using numbers 1 and 2 as many times as you want, create all the subsequences of size 2. You can repeat the values also. So is 1 1 a valid subsequence? 1 2 is a valid subsequence. 2 1 is a valid subsequence and 2 2 is a valid subsequence. There are 4 valid subsequences. Okay. Now if I give you an array, let's say my array is 1 2 1. From this array, if you have to form the subsequence, is 1 1 possible to form from this array? Yes, because you will take this one and this one. These two elements solve the problem. Okay. From this array, can you form the subsequence 1 2? Yes. You take this one and this two, 1 followed by 2, you can form a subsequence. Can you form a subsequence 2 1? Yes, because you take 2 followed by 1. Yes, we are able to form. Can we form a subsequence 2 2 from this? No, we cannot form, because if we select this 2, after that there is no 2. So can we say for this array, if k is 2, we are not able to form a subsequence whose size is 2. Is that right? That is the minimum possible size of subsequence that we cannot form. Yes. Okay. Let's take one more example. 1 2 1 2 2 2 1 1 1 2. From this array, can you tell me what is the minimum subsequence size of 1 and 2 that you cannot form? Of size 2 we can form. Of 2 size we saw 1 1 1 2. Are we able to form every subsequence of size 2? 1 2 2 1 2 2. Yes, we are able to form. Are we able to form every subsequence of size 3? Are we able to form every subsequence of size 3? Every subsequence will be 1 1 1. Are we able to form 1 1 1? 1 1 2? 1 1 1 we can form. 1 1 2 we can form. 1 2 1 we can form. 1 2 2 we can form. Same way, 2 1 1, 2 1 2, 2 2 1, 2 2 2. We are able to form all subsequences of size 3 using above array. Yes.
But when we have size 3, we might have 3 as well, right?
We might have 3.
Yeah, in the array.
No, k is 2.
Correct.
I'm giving you k as 2. That means the array is built of 1 and 2. And I'm asking, can you form all subsequences of size 3? Is there any subsequence I missed? Yeah, Kumar.
No.
So we have all the 3 size subsequence, every subsequence possible we can make, right?
Correct.
Okay.
But why we are checking the 3 size? That's the question.
No, because question says, tell me the minimum size of which subsequence you cannot form from the given array. Return the length of shortest subsequence of rows that cannot be taken from rows. So you have to return that size.
Okay.
Right? So
now we have to try for 4.
4, absolutely. So go on and think about, for 4 size, what is the first subsequence? 1 1 1 1. Are you able to form that? Yes. Then 1 followed by 1 1 2. See, if you look at 1 1 2, there is a 1 before that. So you have to continue going like that. Right now we are just trying to understand the problem. Can we form 1 1 2 1, then 1 1 2 2, then 1 2 1 1, 1 2 1 2, 1 2 2 1, 1 2 2 2. So this marks every subsequence starting with 1. Then you will go with 2 triple 1, 2 1 1 2, 2 1 2 1, 2 1 2 2, 2 2 1 1, 2 2 1 2, 2 2 2 1, and 2 2 2 2. Is there any of these 4 size subsequences that we cannot form using the given array? Okay, let's go one by one. All ones can be made. 1 1 1 2 can be made. Okay. 1 1 2 1 can be made. Yes. 1 1 2 2. Yes. 1 2 1 1. Yes. 1 2 1 2. Can take 1 2 1 and 2. Yes. 1 2 2 1. Possible. 1 triple 2 also possible. 2 triple 1 possible. Take this 2 or this 2 and we have triple ones. 2 1 1 2 possible. 2 1 2 1 possible. Okay. Then 2 1 2 2 possible. 2 1 2 2. 2 2 1 1. Take 2 2 1 1. Triple 2 1. 2 2 2 1. All 4 twos. 2 2 2 2 possible. So 4 size are also possible. So for this, right now, we don't know the answer. Up to 4, we have validated every subsequence is possible. But if we continue doing that manually for 5 size, 6 size, you all know this is a time consuming thing. But now let's try to understand how we are selecting these subsequences. Okay, so when you are forming a first subsequence, you are talking about that you want to use 1 and 2 initially. So for example, if you are talking about taking a subsequence of size 5, 4 we have already validated. For 5, if you see, main question is you will have subsequences starting with either 1 or 2. Is that right? If I ask you, if you have to start every subsequence either 1 or 2, how many elements of this array you have to block as starting elements? If you have to start with either 1 or 2, how many elements of this array you have to kind of block as a starting point? Only first 2. That will give you the, because any one of them can take the first place. We all agree with that? Okay. Now, next place, second place that you are filling, how many elements you have to block to fill the second place? Imagine you started with 2 here. Now you cannot take any element from the first part. Now you will have to take the next element from, can I say next to? Okay. So this will cover all the subsequences starting with 2 1 and 2 2. Okay. Same way, for third place, how many elements you will have to block from rest of the elements? For third place, 5 to 7. Is that right? For third place, you have to choose from here. For fourth place, For fourth place, you still have ability to choose from 1 or 2. Is that right? Yes. Now for fifth place, do you have any option left? Do we have any option left for fifth place? Nope. Now think about it. Can we form 2, 2, 2, 2, 2? Can we form this subsequence from the given array? You have the elements in front of you. Can you form 5 2s? We can. How? You start with this 2, take this 2, take this 2, take this 2, take this 2. You are able to form. Then what is the 5-length sequence that we are not able to form? We see we are able to form this. Then what is the 5-number sequence that we are not able to form? Yeah, guys, can you tell me? From here, let's choose a 2. Yeah, from here, let's choose a 2.
Why we are restricting to choose only one from the first two?
No, we are restricting both 1 and 2 because it can be
Correct.
starting with 2
But,
or it can be starting with 1.
Correct. But if we choose, for example, 1.
Mm-hmm.
So for the second position, can't we choose from the same set?
You can.
That's where I didn't understand. But we are restricting 1 and 2, and the index is the
So
0, 1.
we are saying if first place has to be filled with every possible choice that is allowed.
Okay.
Then you will have to put a boundary here. Although you can choose 2 numbers also from here, but you will have to put a boundary here. Do you agree? Without that boundary, you cannot form all possible subsequences.
Correct.
Yeah. So we are just doing that, but we are not saying you cannot choose 2 values from here. You can still choose 1, 2.
Okay.
But you need a set available so that you can choose any of these values. That is the group we are talking about. Right?
Okay.
Okay. Now see, we have chosen 2 from here, chosen 2 from here. From here, what do you choose so that you are not left with any other option for 5-length sequence? Imagine if I choose 1 from here. From third, if I choose 1, I'm choosing the last value. I choose last from here, last from here, last from here. And if I choose the last from here, can I form 2, 2, 1, 2, 1?
No.
Is it possible for me to form 2, 2, 1, 2, 1?
No.
Not possible. Any other example can you tell me which is not possible?
Just got 2, 2, 1, 2, 2.
2, 2, 1, 2, 2. 2, 2, 1, 2, 2 is also not possible. Yeah. And if you choose 1, 2, 1, 2, 2, is that possible? That is possible, ideally. 1, 2, 1, 2, 2. That we can do in early also. But we are trying to kind of exhaust in such a way that there is some sequence we cannot form. And why we are drawing these lines, I hope that is also clear to people. These are not mandatory lines. You can still choose 2 elements from here, but they are kind of giving you the scope of selecting a value from the given range. Yeah. So ultimately, if you try to internalize on this idea, then what is it that we are trying to calculate and count from the given array? Here, if the parts are 4, 1, 2, 3, 4, our answer is 5 length cannot be formed. That is what is our conclusion. Then what is it that we are trying to observe and solve the problem? Is there any observation, any conclusion from here? Let me give you one more example. Let's say you had an array 1, 1, 1, 2, 2, 2, 1, 2. For this, can you tell me what is the answer? what length subsequence you cannot form, and what is that subsequence? What length cannot be found? Okay, Madhusudan says 1211 cannot be found. There is something smaller than this. Are we able to see anything smaller than this that we cannot form? Is there any subsequence of length 3 that you see we cannot form? Okay, good. Harini observed that. Madhusudan observed that. They are saying 211 is not possible. Do we all agree with that? 211 is not possible to form if you see above subarray, above array. So what they actually tried to do, they have drawn a line here, and they are choosing the last value from here, 2, and choosing a value from here, because after this 2, or choose any 2 from here, after this there is only single 1. You will not find another 1. If you choose any of these 2 ones cannot be followed after that. Okay, so this is, if we draw this line, if you choose first number from here, after that, if you choose this, after that, you are forced to choose the next number from after this. That means after 2 ones are not possible. If you select 2, then 1 is not being possible. So answer for this is 3 rather than 4. Okay, now in nutshell, if we observe what we are seeing on the screen, number of components having all k elements at least once. Awesome. Does everyone agree with Harini's observation? She's saying select a component, even if you select this component, or let's say you restrict to this component. Here you have all the numbers from 1 to k. Here also you have all the numbers from 1 to k. Let's say we are putting this. Let's in fact bifurcate like this. So you have how many segments you are getting where all the numbers from 1 to k are there at least once. How many full segments you are getting? This is first segment where 1 to 2 are at least one time. This is second segment, third segment does not have all of them. So if you can find out those segments, your answer is these segments plus 1. Is that fair? Is that right? Okay. Now question is all about finding these segments count. How do you count how many segments have all the numbers from 1 to k? What can we use to find the segment like that? Okay, we can use a set. Awesome. So we start with the set. You take the first element, put that into the set. It is 1. When do you stop? When do you say your segment is complete? When size of the set becomes k. Okay. Right now set size is not k, so you have to continue. You see another one, put that into the set, no change. Another one put into the set, another one put into the set, another one put into the set. Now set size became 2. So you say my 1 component completed. After 1 component completed, you start another component. So clear your set. Again, you start with the set, which is fresh. You are basically clearing it off. And then you see first number is 2, add it to the set. Next number is 2. If you add, nothing happens. 1, if you add, now set size again became 2. So you will say, hey, my count becomes 2. Okay, again reset. Set becomes empty. And you start with 2. And your array got over. Once your array got over, you realize that third set did not complete for me. And your component size was 2, and it was answer for that is 3. You cannot form some subsequence of size 3, and that is the desired answer. So its code was very small if you use the set-based approach. Yeah, but coming up with the observation, it was tricky, it was hard. Okay, so good learning. Did anyone find any other solution when you were up solving, if you have gone through discussion forums? No? Great. Yeah. So upsolve this question. Now we have visualized an approach. We have learned something. Cool. So this completes our yesterday's contest.